Institute is going to say a few words. Ted?
Hey, thanks very much, Rick. Thanks to everyone who's on this webinar. We appreciate it. We're glad to see the response. We're very, very excited about this Master's Scholarship Program. As you well know, it's sometimes very difficult to find a scholarship that has both tuition and stipends for a master's degree. And the reason we're doing it is because we're trying to get more students in the Texas area, specifically North Texas, who have interest in semiconductors and may want to pursue a job in industry after following a master's in semiconductors. Of course, you can always stay on and get a PhD also, but the program has support definitely through the master's level. We have had a lot of questions about the stipends. Let me just clear that up. The stipend is consistent with what we pay our graduate students, et cetera. But the main point is that this is a really rare opportunity to be able to get your master's in electrical engineering or mechanical engineering or materials science fully paid for, tuition paid for, and with a full stipend. We do expect the program to be very competitive based on the response we've gotten. And so I would encourage you to, if you're interested, to certainly put your best foot forward on your application and make sure you get your applications in for both the department and the scholarship early on, and we'll go from there. So, Rick, with that, let me pass it back to you.
Okay, thank you, Ted. Again, sharing my screen here.
Yeah, Rick, I think Christy's got her hand up too.
I'm sorry?
I think Christy has her hand up.
I just wanted to say that this meeting is being recorded. This webinar is being recorded, and by attending, you're consenting to the recording. It will be used for information purposes and marketing purposes.
Okay, thank you for that, Christy. Okay, so we'll begin. I'm going to go through a few slides to give you some information about the fellowship. We've got a couple professors joining who will also talk about their research. Before I get into the slides, though, I want to put this QR code up. This will take you to our website with the complete details about the fellowship, the process for applying and all of that. So I'll leave this up here for a few minutes if you want to capture that QR code. I will also put it up at the end of the presentation, but in case you have to leave early, I want to give you the opportunity to capture that. Okay, we will go ahead. So this is our agenda for the webinar. We will talk about, give a little bit of introduction about, why this program is important. And then we'll follow up a little bit as Ted started talking about the need of the industry, this opportunity, what it entails, what the requirements are to be eligible to apply for the fellowship, what you can expect to get out of it besides just your master's degree, and then have a slide on how to apply. And then we will turn over the presentation to a couple of our faculty advisors, Dr. Nandika D'Souza, who's in mechanical engineering, Dr. Bruce Ganade in materials science and engineering. And these are two of the 20 participating faculty advisors. If you go to our program website, it will list all 20. You can select on one of those and it'll give you details of their profile and also what kind of projects they would have for a master's student who was selected for this fellowship. And then we will close out the meeting with a Q&A, give you an opportunity to ask questions of anything that's not covered. We'll try to answer them here. If we can't get to them, then we'll try to get back with you with an answer. Okay, so I just want to, if you didn't see my slide, I'm not a young person. So I've been around the industry for a while, and I want to give you just some perspective on what some of the key inflection points have been in semiconductor demand over the last 40 or 50 years. When I entered the industry, the microcomputer, personal computer, was just kicking off. And of course, that drove a lot of semiconductor demand. If you worked in an office then, you started seeing the typewriters disappear and being replaced with a personal computer on the desk. And of course, that allowed you to, not only write your messages, make your presentations, of course, using Excel, you could do much more, much faster than what you could previously do on a calculator. So that drove a lot of demand in the industry through the 80s. And then in the early 90s, it was the mobile phones. That became available in the early 90s. Of course, I'm sure that predates all of you, or most of you, that certainly that are applying for this fellowship. But, used to, if you left your house, you couldn't talk to anyone until you got to work and got to another phone. If you had to, you would find a phone booth and pull over there. So mobile phones drove a lot of demand of semiconductors. And then the latter part of the 90s, it was the internet. And of course, the internet, allowed you to link your personal computer beyond those in your office to people across the world. And of course, that brought about where you could email anyone across the world. You could access anything that was on the internet. And of course, that grew over time. And, that replaced much of what you used to go to the library to get. And then in the 2000s, the smartphones, that brought everything, the personal computer, the internet, the mobility to your hand. And of course, as you know, that drove a lot of semiconductor demand. And then in the next decade, that was, it became smart everything, putting that type of capability into autos, appliances, security systems, et cetera. So of course that drove a lot of demand. And then of course the latest, and the one that's probably going to go far beyond these previous ones, which were large, is AI, and that becoming proliferating throughout everything. Now, in the backdrop of what was happening during this time from the 90s through the 2010s, and the reason you think, well, if there was so much demand, and we all know these were very big, why don't I see a semiconductor factory in, every maybe not every town, but every big city, every state? Well, what was happening was the manufacturing was offshoring, most of that to the Far East. And of course, one of the big drivers for that was, labor was cheaper. And so a lot of the new fabrication facilities were being moved offshore. Well, what happened in the 2020s, as you know, COVID came, and there were a lot of supply chain integrity issues. And if you have a factory sitting here in the US and it's relying upon getting a chip from, across the seas, that caused a lot of problems in being able to get products out. And so it became seen as an imperative to reshore manufacturing. And of course, I think, as you know, there's also national security issues about not having capability in the US to do the manufacturing from start to finish. So I bring this up to say we're at a double inflection point. I think you're going to see the demand really skyrocket with AI, and you're going to see manufacturing coming back to the US. So that's going to, increase the need for a lot of engineers to make this happen. And so with these things in mind, that's what drove this North Texas Semiconductor Institute to get this funding for this fellowship. And so that's kind of the backdrop. So to put some numbers to that, the semiconductor manufacturing capacity is expected to triple in the next 10 years in the US. So we have the increasing demand and a lot of people retiring. People that started back when I did have reached near the end of their careers, and those people are retiring. So there's a huge demand anticipated for engineers to work in the semiconductor industry. And Texas in particular is as we say here, at the epicenter of this growth. It's Texas, if you didn't know, is already home to 17.5% of the nation's semiconductor workforce. There's several leading semiconductor companies here in North Texas: Texas Instruments, or TI, Global Wafers, Honeywell, Leonardo DRS, Coherent, Qorvo. These are companies that have operations here in North Texas, and a number of these are expanding, significantly expanding. If you live around here, you've probably read about this in the news, but if you haven't, for example, Texas Instruments is building a huge new fab in Sherman, which when built out to completion will be their largest manufacturing facility. Global Wafers has also built a new facility, which will be their largest, and it's to produce wafers, silicon wafers, to supply the semiconductor manufacturing fabs. So this demand, it's projected that Texas alone is going to need about 1,000 new master's level trained professionals in the semiconductor field each year. So to meet that, we've got to attract a lot of people into this area of study, and again, we think this fellowship will be one way to help facilitate that. So let's talk about the fellowship. It's a competitive fellowship, as Dr. Moise mentioned. It's going to support master's degree candidates who are selected for the fellowship in one of these three master's degree programs: material science and engineering, electrical engineering, or mechanical engineering. Students that are selected for the fellowship will start in either fall of 2026 or fall of 2027, and we currently have the funding to support right now 20 students, and that would be 10 for each cohort. This fellowship will pay full tuition for 4 semesters and a stipend for 5 semesters, which means that you would take the fall and spring of your first year, and then during the summer after your first year, you would be doing research. And so that would be a total of 5 semesters of stipend. We would expect you to finish the program in 2 years. To be eligible for the fellowship, you must be a U.S. citizen or a U.S. permanent resident. By the time you start the program, you have to receive a Bachelor of Arts or a Bachelor of Science degree in one of the physical sciences like chemistry or physics, or in an engineering discipline. Now, applicants with other bachelor's degrees may be considered on a case-by-case basis, but we expect most of the applicants and those selected would have either a chemistry or physics or an engineering undergraduate degree. You must apply and be accepted to one of the 3 MS programs, and we'll talk more about that in a few slides. But so what you would need to do is, make your application to one of the 3 degree programs, master's degree programs here at UTD. Again, material science and engineering, electrical engineering, or mechanical engineering. And if you're a UTD student currently on the fast track or auto admit, you're also eligible to apply for the fellowship. The requirements: you must have a minimum of a 3.0 on a 4.0 scale, GPA in your junior and senior level work, and in any graduate work that you've already completed. You also have to apply and be accepted as a fellowship recipient. So as Dr. Moise mentioned, you will need to apply both to the MS program that you select, and then also do the fellowship application. Also, if you're selected and you're part of the fellowship, part of the program, you have to complete the graduate certificate in semiconductor technology. Now, this will be part of your MS curriculum, but this is really another benefit. Not only will you have a master's degree focused in semiconductors, you will also leave here with a graduate certificate in semiconductor technology, which will signify that you've taken courses that have prepared you for the semiconductor industry. If you receive the fellowship, you must remain enrolled as a full-time student, and this is a thesis-based master's, so you have to complete a thesis in a semiconductor technology related research area. And this is the graduate certificate in semiconductor technology. I'm not going to read through all of this, but it's a 12 semester credit hours, which will be part of your courses that you take as part of the MS requirement. But there will be a few specific courses that you will be required to take. So you will take electrical, optical, and magnetic materials as a required course. And then you will take either fundamentals of semiconductor technology and manufacturing or semiconductor materials, defects, and devices. And then you'll take 2 courses out of this list here, which I won't read. But anyway, as you can see, this certificate is very semiconductor focused, very semiconductor manufacturing focused. So when you take these courses again, it's going to better prepare you to step into the industry and be ready to contribute, right off the bat. Again, in addition to getting the degree, there's also professional development benefits. As a fellowship recipient, you will also receive funding to attend the MS Semiconductor Scholars Conference. That will be held at the Texas Institute of Electronics in Austin. So you will go and meet other students from other universities in this program. And there are some, I think UT Austin, Texas A&M, and maybe a few others. But you will get to meet and mingle with those students and, share what you're doing in your research. The North Texas Semiconductor Institute will have a seminar series where we bring in engineers from industry to discuss their work. So that will give you a better idea of, with this degree, what kind of work you will be doing. We will also try to get you coordinate pairing you up with an industry mentor, who will be able to help you again, be thinking about what kind of work you will want to do after you get your degree. And, of course, share their experiences of, what's relevant, what you may pay, what's really helped them succeed in their careers in the semiconductor industry. And then also, and this is a very exciting part, is arrange visits to local industry sites. And, if you haven't seen a state-of-the-art semiconductor manufacturing fab, I think it will really blow you away. And one thing I failed to mention earlier, but I should mention is, as the industry was offshoring, that was done because of labor. Well, why is that not as important now? It's because if you go look in these fabs, if you went in a fab in the 1980s and look through a window, you would see people walking around all over the place. If you go look in a fab now, they're fully automated. You can look into a fab that may be the size of a football field and only see 2 or 3 people walking around in there. So that's one of the other things that's going to make this more viable. This onshoring of manufacturing to the U.S. is that the fabs are automated. Now they still need the engineers. We still have to come up with new processes, to modify the processes, to control the processes. You still need them to design the circuits and things like this. But automation is a key part. And when you see these industry sites, you will be truly impressed. Okay, so the key dates, again, what you need to do is apply for the MS degree in material science and engineering, electrical engineering, or mechanical engineering no later than January the 15th. You also need to apply, after you've applied for one of these programs, apply to the North Texas Scholar Program Fellowship by January 15th. And when you fill out the fellowship application, you will have to indicate which program you've applied to. Now, you don't have to be admitted when you submit the fellowship application, but you at least have to have made your application to one of those 3 programs. As part of the program fellowship application, you will write a short essay telling what area of the semiconductor technology research you're interested in, and also tell us something about your future career goals, why you want to work in the semiconductor industry. You will also identify 3 to 5 potential thesis advisors from the faculty list. As I mentioned from our website, there's 20 participating faculty, so you can read their bios and see what kind of research they're doing and select 3 to 5 of those who you would be potentially interested in working with. So the program will, working with the departments, will select 10 fellowship awardees, and they will be notified by next March. The program will start in fall of 2026, and then for the first cohort, it will complete in spring of 2028. Okay, with that, and again, we'll get to Q&A afterwards, but with that, I want to now introduce you to 2 of our faculty, Dr. Nandika D'Souza from Mechanical Engineering and Dr. Bruce Ganade from Materials Science and Engineering. And Dr. D'Souza is going to start out, and I'm going to stop sharing. Okay, and let's see. Okay, Dr. D'Souza, can you share now, please? See if that works.
All right. Are you seeing my screen?
Yes.
All right. Let's see. So I thought I would show you kind of first the concept which we are chasing. And what we do is we use polymeric materials and we introduce a range of nanoparticles. And the core issue that drives most of our work is that we look at the distance between nanoparticles and the type of particle, and then we are able to get many different properties. So the different applications that we're working on, we have one area we're working on is in batteries. You can form these sensors, and the 2 topics that are needed are to track different gas evolution so that you can see early warning to track whether a battery is in a dangerous zone for creating fire. And then the second area I wanted to show you is this idea of doing subsurface. So we've used these sensors below the surface, and then we track changes in impedance, which then you can monitor even in liquids. You can track whether there is any kind of, again, we track whether salt is permeating through. That changes the properties of the substrate. And the last application that we look at is we look at pressure. So the 2 things that we look at in terms of even in this battery application is whether any kind of stress is changing dimensions of a particle, or you get the particle itself changing dimensions, which would be gas. Here you see that should you get subjected to different kind of cyclic loads, the monitoring of the function that we would chase is the change in resistance. So the different applications we've done before are going to be are shown here, and we work on different geometries. We either put porous centers, solid surfaces, core sheath applications. We put particles on top of fibers, and these are the different geometries we put. This is a subsurface application. We've done impact monitoring so that if something projectile strikes it, you can also note a change in properties. And I thought I would show you one of the recent applications. So this is a drone application where you can see this is going to be the structural element you can trace on the surface. So instead of attaching many sensors for monitoring either changes in weather or you can go into areas which are very dangerous and humans should not enter there. You can send these drones in to track, so you can put chemical sensors on there. And then the concern is that drones may actually need to be brought down in a safe way should there have some kind of challenges either in the motor or in the structure. So we have embedded structural health monitoring in the core. So these are kind of different applications, and we use a whole bunch of different equipment. So I thought I'd show you that, and I'm happy to answer any questions.
Thank you, Dr. D'Souza. Will you be able to stay on to the Q&A session?
Yeah.
Okay. Okay, we will go ahead and let Dr. Grenade present his, and then we'll move to the Q&A for everyone. So share that again.
So I'll just share this while Rick's pulling up the slides. Mine are much more interesting than Nandika's. So, I mean, just without a doubt. So, before we even start, I can tell you that. So, Rick said that when he started that he was old and had been at this. Well, I've been at it, longer than Rick, so I'm older than Rick too. So yeah, just a little bit about me in case you want. And I guess Rick, you're going to probably share the slides with them so they can find it, and go look at it later. But I'm sort of semi-retired, guys. I'm here as emeritus, but I spend a lot of time with my 3 grandkids, so that's a big part of what I do. But if we can go to the next one, please, Rick. So there are, and you might have to click on the videos to get them started, Rick. But I'm gonna tell you about 3 things that we work on. One of them is neuromorphic sensors, and if you're not familiar with neuromorphic sensors, this is a particular one that is a neuromorphic imaging sensor. So it's basically a camera, but it has some unique properties. This particular, if you guys are in, if you know about normal framing sensors, basically what happens is, you collect a frame at a time, and that frame at a time reads out. And so, your digital camera that you use on your phone or other digital cameras all work that way. For a neuromorphic sensor, it behaves more like your eye. And the idea being that, I have a lot of pixels, but instead of reading out a whole frame at a time synchronously, I read out an individual pixel asynchronously, and that pixel only fires when there's a change. And so, if I'm in an environment where I need to have low bandwidth or I need to have low latency, these neuromorphic sensors are really useful for that. And, for the electrical engineers, I mean, what sort of makes them unique is that on the front end, where what would be, the photoreceptor, which is, comparable to or representative of the cones in your eye, is that because I'm running that transistor in this front end amplifier in subthreshold, it has really high dynamic range and it has really high sensitivity. And so what happens is that when there's a change in intensity on that pixel, either up or down, I get an output from the pixel that says, okay, my location is X and Y in the array, the time that I actually fired, so this is when it happened, and then whether or not the intensity went up or the intensity went down. And so if I have a perfectly still image, it ends up nothing changes, right? I get no data out. And I don't know, Rick, if on the upper right-hand one, you can start that now. But so you guys look at the one in the middle, it's 2 guys playing tennis or a guy and a gal playing tennis, and you can see them moving around. If you look at the one on the right, this is what would come out of a camera that's based on neuromorphic sensors. These are only the things that are changing. Now you'll see there's a lot of background clutter and all, and that's because the sensor has some pixel problems, but the primary thing that's changing is just the people, right? I mean, that are moving. The rest of the image is still. And one of the reasons then you say, well, gosh, okay, that might be kind of interesting, but why do I care? It ends up that there are things like, if you look at the little expanded area below, when we first started looking at these guys, you see the tennis ball, in the middle of the picture, and you see this black dot below the tennis ball. What that actually is the shadow from the tennis ball, but it is tracking because, the intensity went down from where it was because the shadow is darker than the area around it. So, so you might say, okay, gosh, well, that's kind of fun. What do you actually use them for? What we get funding to use these for is to try to track objects in space, especially in low Earth orbit, where, things are fairly stable and fairly constant. But if you're trying to see an object, and it could be anything from debris to looking for, satellites, there's a lot of things in low Earth orbit these days, like the Starlink satellites. Are there things that are coming in close contact? So folks like SpaceX actually hire, there are companies that have started, they're not using neuromorphic sensors, they're using other techniques, but before SpaceX launches, they actually hire companies to tell them how much debris is in the general area where they're going to launch and where, before they get into orbit, so that, they don't run into things. So there's a lot of applications in space domain awareness, to try to use these to track objects. So that's one of the areas in general, neuromorphic sensors. If we go to the next one, Rick. One of the other areas that I work in, and Dr. Corvedo's on here, and we work together on this, is this idea for electronics for harsh environments. And in particular, we're interested in things that go into space. And you might say, well, gosh, okay, how's this connected to neuromorphic sensors? It actually is, because the neuromorphic sensors in their current embodiment and the current way that they're designed for that front end, the topology, is very sensitive to radiation. So, understanding why they're so sensitive, we know why they are now. It's because that transistor runs stub threshold. How do you actually design circuits that are more, or similar capabilities, but that are less sensitive? And a big part of that, though, is this idea that we have to be able to test these guys in a radiation environment. So, some of the pictures on the left, especially the bottom left, that's us testing things at Texas A&M. We go down there to use the cyclotron. We also have capabilities in the lab over here. I happen to sit in Rockwest, for doing testing using lasers instead of heavy ions. We've got X-ray sources. So to be able to look at these devices and say, okay, gosh, we've made a change. It's better than what it used to be, or it's worse than what it used to be in terms of how it responds to radiation. This is important, at least in our mind, because if someone puts something in space, it's hard to go up and repair it, right? So I want to make sure that it's going to last for whatever the time frame that, I hope that my satellite, if Starlink satellites and they're supposed to last 4 to 6 years, I want to make sure the electronics don't fail in less than 4 to 6 years. So we do a lot of testing. We work a lot with Texas Instruments on this. We also work with the Department of Defense on this. They're interested in how we make these neuromorphic sensors more robust, specifically for putting them in space and for space applications. So that's another area. It's a bit more around test and evaluation, but it's for a wide range of semiconductor devices, from these neuromorphic sensors to power devices, to memory devices. So if you're interested in, especially if you're interested in physics, I mean, why these radiation events affect devices, it's all kind of comes down to basic physics. It's just, how do you make the designs more tolerant to those energy deposition events? So that's the second area. And then the third area, Rick, if you'll flip to the next slide, please. This one is actually considerably different. This is a joint project we have with UT Southwestern. And the idea is to be able to detect kidney stones. So you might say, gosh, what's this have to do with, electronics and semiconductors? Well, what makes it unique is the sensing modality that we use. There's a bunch of chemistry that goes around. So if you like chemistry, that, it might be of interest to you, but, it ends up that a lot of people get kidney stones. Something like 10% of everybody in the US will have a kidney stone sometime in their lifetime. The other piece that's interesting is if you've ever had a kidney stone and you're over 50 years old, there's over a 50% chance you're going to get it again. So being able to prevent kidney stones, or to be able to give you information to try to prevent them, and it ends up quite preventable. If ahead of time, if you drink more water and you stay hydrated, and all your chances of coming back is less. But so what we developed or are working on with a group down at UT Southwestern, some good friends, is come up with this inexpensive point of care system. So what we do is we shine the light through a solution that's made up of urine and some calcium oxalate crystals And if the calcium oxalate, which is what kidney stones usually are made out of, if they grow, it suggests that your urine says you're in a state of forming kidney stones. If the crystals that are there shrink, it says everything's fine. You're actually below the threshold for forming kidney stones. How we make those measurements is where the semiconductor part comes in. We use a semiconductor laser to shine the light through. We use a power meter based on a semiconductor device to be able to measure the scattered light. But what we're most interested in, and what I'm really interested in, if somebody is interested in the topic, is to look at the scattered light. There's a technique that's called lensless holography. And if you look at the diffraction patterns off of these crystals from a laser, from those diffraction patterns, you can actually tell not only what the crystal size is, but you can also get information about the morphology. And why that's important is, depending on if they're calcium oxalate stones, they'll have one morphology. If they're calcium oxalate monohydrate versus dihydrate, or if they're uric acid stones, they'll have a different morphology. So we're trying to develop this lensless holography technology to be able to add, to our current system that just matters light scattering. So, again, it's how do we use image sensors, and again, how does these all tie together? I think there's a benefit to, rather than using just a standard framing sensor, to actually using one of the neuromorphic sensors to look at how these items are changing with time. So, it all hopefully sort of ties together. We're looking at new neuromorphic sensors, applications to different things, and then how do we actually make those sensors more robust? So with that, I think I'll stop. And Rick, if we want to do questions and answers, or however we want to do this, would be great.
Okay. All right. Thank you, Bruce. Before we get to the Q&A, I just want to put this QR code up one more time. If you missed getting that earlier, this will take you to our website. And again, you can see the profiles on all the participating faculty, learn more about the process of applying and things like that. The things that we covered in this presentation today, it will step you through how to, what you need to do in terms of applying for NILMAS in one of the programs and also applying for the fellowship. So with that, we will go to the Q&A session. Stop sharing here.
Hey, Rick?
Yes.
We have received in the Q&A a question: can PhD students in computer engineering apply? I'm doing a master's on the way in computer engineering too. Are they eligible?
This program is, again, it's only for electrical engineering, mechanical engineering, and material science and engineering for a master student. And this will be for master students who are starting their masters in fall of 2026. So this program is specifically designed to bring in 2 cohorts starting those 2 years.
Thank you. We've received some other questions in the chat as well. One is, respected professors, what will be the acceptance criteria and average how many students apply for the program?
Well, if you're talking about the fellowship program, this is the first year, so we don't know. We hope there's a lot of applicants. But the selection criteria, it will be, it'll be competitive like any other fellowship or scholarship would be. So it's based upon your academic performance, what you express as your interest in working in this industry, what kind of research you want to do, why you want to get into it. So, it's important, certainly if you have a stronger academic record, that will improve your chances, but also expressing well what's attracting you to this fellowship, and why it's a good fit for you, what some of your career goals would be after you complete this master's program.
There's another question that says, thanks for the valuable information. Spring 2026 is accepted by this fellowship. I think they mean if they apply for spring in 2026, they'll be accepted to this fellowship or eligible for this fellowship.
Again, it's only for people starting the MS program in fall of 2026. And then there'll be another cohort in fall of 2027. So I know that seems a bit restrictive, but that's the way the program and the funding has been defined.
I'm just going through. Let's see. I see where Dr. DeSouza already answered. If I get admitted to the fast track program, would I be able to take the semiconductor certificate classes while sorry, somebody just posted and I lost it, while I'm finishing my undergraduate? And she said that they would need to talk to the advisor to have the right selection of courses.
Yes.
I have another question. I have an admission for a PhD in electrical engineering at UT Dallas. May it be possible to study at this MS program? I'm an international student.
Well, again, the fellowship, if you're international, if you're a U.S. citizen or permanent U.S. resident, you're eligible to apply. But again, this is for master's students. This is not for students that want to go right into the PhD program. Now, you may, as Dr. Moise said at the start, you may go through this program, complete your master's, and write your master's thesis, and then based upon the research you're doing, you may decide you want to continue for a PhD. Certainly, that would be a possibility. But you enter this program to get a master's degree, a thesis-based master's degree. And then, of course, the intent is for most of the recipients to go into industry with that degree. But again, if you've completed that requirement, then certainly you can go on and continue and get your PhD.
Thank you. The next question in the chat is, I did my bachelor's in computer science and engineering. After that, I completed MS in computer information system. I'm currently working on AI research in ROV robotics for underwater. I'm interested in doing a master's in electrical engineering. Am I eligible for this program?
So if the electrical engineering program accepts you into their MS program, then you're eligible. So that would be up to the EE department to see if they, with your background, if they accept you now. If you're going to have to take a lot of makeup courses, then it lessens the chances that you would be selected, because this is a two-year program, and we wouldn't be able to fund an extra year of undergraduate courses to make you ready and be ready to enter the EE program. But again, that would be up to the EE department to decide if they accept you into their program, and then we will take the recommendations of the departments along with the North Texas Semiconductor Institute, and that's how the selection will be made for the 10 recipients.
The next question is, since I'm graduating in December of 2026 and planning to apply for fall of 2027, would I still receive acceptance decision in 2026? That would.
So you would, well, if you're starting in fall of 2027, the acceptance decision would be in March of 2027 for the second cohort.
Thanks for the value of same thing. Spring 2026 term is accepted by the fellowship. No, it is not. We've answered that one. Next question. I have been admitted to the MSEE program at UTD for fall of 2026. I noticed the program requires mention U.S. citizenship or permanent residency. Since I hold an F1 visa, I wanted to ask kindly if I would still be eligible for this program or if there are any exceptions.
No,
No.
due to the funding source, there's no exception. It's U.S. citizen or U.S. permanent resident.
I'm trying to figure out, this one says, this is a follow-up to, she says, I main studied, or the student says, I main studied two programs together. Is it possible? I think it's the PhD in electrical engineering. So if they're already in the PhD program, then it's not eligible, correct?
Correct.
And the last question that I see in the chat is, UT Dallas the only school participating in this program, or other Texas schools that have similar programs sponsored by the semiconductor industry?
there are similar programs. There's one at UT Austin. I believe, Ted, you may want to answer that question. You probably know better than I.
Right. So this is sponsored actually by the state of Texas and the Texas Institute for Electronics, not industry, although it's certainly there to benefit industry, just to clear that one up. As Rick mentioned, UT Austin has a program like this. I believe University of Houston, UNT, and perhaps a couple others, but each school is kind of approaching it in a different manner. And so you'll have to go with talk with those schools or look at the school's websites and see what they're all, how they're implementing it at those specific universities. But at least there are at least several more within Texas.
Final question, and
I was just going to say, before we go on through these kind of program questions, does anyone have a question for Dr. D'Souza or Dr. Grenade? Because they may not want to sit through all these detailed questions. So do you have any specific questions for them regarding the research? And let's give that opportunity before we go on.
don't see any questions in the chat or the Q&A specific.
Okay. Okay.
So is there a program about
wait.
In person or remote? It's an in-person program. Just to be clear on that, because there are multiple labs associated with it, and you have to do work in one of the labs in order to write a thesis with one of the experimental thesis with one of the advisors mentioned.
We have a question for one of the advisors. I have a hand raised. Just one moment. I'm going to allow the mic. Shri?
Hello.
Yes.
To
Yes.
Dr. Bruce, I just wanted to know if neuromorphic sensors can be used for like fully autonomous spacecraft, that can navigate and without any Earth contact to make decisions for.
So sure. I mean, the whole point for and one of the reasons, the space applications are, sort of high on the list is because, the ultimate goal is to go from the neuromorphic sensor, use neuromorphic processing to be able to make decisions. So, autonomous vehicles, autonomous driving, autonomous docking is one of the applications. I mean, it's not there yet, but that would be the hope, that you go from basically a spike, which would be comparable to neural activity, to some action after that. So yeah, they would be applicable to autonomous maneuvering. But yeah, so
Yes, thank you.
Okay. So there's no other questions for the professors. We'll go back to any other written in questions, Christy.
No, the last one was, is this program face-to-face with, which is, hang on. With I think maybe Dr. D'Souza and Dr. Grenade, if there's no more questions, if you're welcome to hop off. Thank you for joining.
Thank you very much. Okay, what was the next question?
There's one question, excuse me, there's one question for the fall 2027 cycle. Would the application deadline also be in 2027?
Yes, it will be similar. It would be January of 2027. We will update the website with the specific dates after we get through the first cycle. But yes, it would be January 2027.
I do not see any more questions in either the Q&A or the chat.
Okay. Okay, well, we'd like to thank everyone for joining. If you do have further questions, if you go to our website, you can see how you can contact us there through the North Texas Semiconductor Institute Fellowship email. And you can feel free to email us with questions at any time, and we'll try to get back to you with an answer for any other questions that you may have. Okay, is that any, Christie, is there any others? That's it, right?
Do not see any more. I did drop
Okay.
the website in the chat for everybody
Okay,
as well.
great. Okay. Okay, thanks, everyone.
Rick,
Thanks
thanks for
for coming.
setting this up. Yeah, thanks.
Mm.
Thanks, folks.